Assalamu alaikum. I hope everyone is fit and fine. In this video, we will solve the radical equation of type 2. In my previous video, we solved radical equation of type 1. Let's solve question number 5 of exercise 1.4. We are supposed to remove these radical signs. How we are going to remove it? We'll square both of its sides and we'll write squaring both sides. By squaring both sides, we are able to remove the radical sign. And here we have square root of x plus 60 whole square. On the left hand side, if you see, we are having first algebraic identity, which is a square. So the square of first term, then 2ab, and then we are having square of the second term, which is b square. So x plus 21 square root of x plus 21 whole square. And on the right hand side, square will get cancelled by 2, so we are left with x plus 60. Now let's solve the left hand side. Square will get cancelled by root x plus 5, and last term square will get cancelled by 2. We are having x plus 21. And here we have already read about the property of radical. Here we have, if we are having separate radical signs, we can combine them. So we can easily multiply the two terms. And the right hand side will be as it is written. Now x plus x becomes 2x, and 21 plus 5 becomes 26. And here we will multiply the two terms. Here we'll get x square plus 21x plus 5x, and here we have 505, and here we'll get this. Now we'll take the term without the radical sign to the other side, and we'll be left behind with just this term. We'll solve it. 21x plus 5x becomes 26x plus 105, and here we have 60 minus 26 plus x minus 2x, right? So we'll just solve the right hand side. We'll just simplify it. So here we'll get 34 minus x. So our type 2 is converted into type 1. We are left with one radical sign. We'll take the square again. We'll write squaring both sides. And we'll take square on both sides like this. 105 whole square. And here on the right hand side this. So square is on 2, it will become 4. Square is on radical sign, it will get cancelled. So we are just left behind with this term. And on the right hand side, we are having the second algebraic identity, which is a square. So it becomes 34 square minus 2ab and plus b square, means x square. So we'll open up the brackets, we'll open up all the squares. So we are having 4x square, and here we have 104x, and here we are going to have 420. And when you will take square of 34, it becomes 1156, and here we have 68x and plus x square. Now we'll move all the terms to the right hand side. To the left hand side, 4x square minus x square plus 104x plus 68x plus 420 minus 1156 equals 0. Now we'll just further simplify it. 4x square minus x square becomes 3x plus 104 plus 68 becomes 172x, and here we are having minus 736 equals 0. Now we are going to break the middle term. We'll use these two factors. 3x square will as it is. We are having we'll write minus 12x and plus 184x. When you'll solve it, you'll get 172. So let's take common factors. Here we have 3, 4, and 184 is common. So we are left with x minus 4, and then again x minus 4 is the common factor. So we are left with this. Now we'll write either the first both factors equal to 0, so x minus 4 equals 0, or 3x plus 184 equals 0, and then x equals 4, and then x equals minus 184 by 3. We'll not write down the solution set. Before that, we are supposed to check the values. So let's do the checking process. We'll insert each value of x in the given equation. Let's write the given equation. Square root of x plus 5 and square root of x plus 21 equals square root of x plus 60. So instead of x, we'll write 4 plus 5, and then square root of 4 plus 21 equals square root of 4 plus 60. We are having 9, we are having 25, we are having 64. Open up the square roots, we'll get 3 plus 5 equals 8. So this means x equal to 4 satisfies the given equation, so it will go into the solution set. Let's check for the other value of x. I'll insert the values directly because the equation is already written. So instead of x, I'll insert minus 184 by 3 plus 5, then square root again minus 184 by 3 plus 21 equals minus 184 by 3 plus 60. These are two fractions. We'll make them one fraction so that we can see whether the left hand side is equal to the right hand side or not. So in all the three fractions, we are having 3 as an LCM. Okay, so let's write down the numerator plus 15. Here also minus 184, 63. Here also 3 is the LCM, minus 184 plus 180. So let's solve it further. We'll have minus 169 by 3. We'll have minus 121 by 3. We'll have minus 4 by 3. Now let's open the square root. When you'll open the square root of 169, it will become 13. Square root is also on minus sign. It will become iota over square root 3. Again, when we'll open the square root of 121, it becomes 11 iota divided by square root 3. Here we have 2 iota divided by 3. If you see, the left hand side is not equal to the right hand side, so this thing for x equal to minus 184 by 3, it will not go into the solution set. So at the end, we'll write down the solution set, and the only value that satisfied the given equation was 4, so it will go into the solution set. And for the other value, we'll write just the extraneous root or the extraneous solution. You can say extraneous root is minus 184 by 3. So this is how we are going to solve radical equations of type 2. In this case, we have taken the square both for 2 times, right? So I hope the steps of working are clear to you. Thank you so very much. Let's solve one more radical equation, which is given in question number 6 of exercise 1.4. Here again, we are having 3 radical signs. So we are supposed to solve this equation for the value of x. For that, we will remove the radical signs, and for that, we have to take the square on both sides of the equation. So we will write squaring both sides. So we'll get square root of x plus 1 plus square root of x minus 2 whole square, and on the right hand side we'll also take the square. Now we'll solve the left hand side, which has become now the identity. We'll open it. So square of first term plus 2ab means we are going to multiply the two terms, and the square of the last term, which is x minus 2 whole square. And on the right hand side, square will get cancelled by the root, and we are left with x plus 6. So now we'll just open up the square. Square will get cancelled by the root. So x plus 1 from the first term, and from the last term x minus 2. And the two terms here 2ab, they are going to multiply. So if the radical signs are separate, you can make them written as in collectively form. Like this, we have already studied the radical properties, so you can easily write it like that. Here x plus x becomes 2x, 1 minus 2 becomes minus 1, and here when you multiply the two terms, you will get x square minus 2x plus x minus 2 equals x plus 6. So let's solve it further. Here, let's say you are going to write it like this. x square minus x minus 2, and these terms will go to the right hand side of the equation, minus 2x plus 1. Here we'll have this x square minus x minus 2, and here we have 7 minus x, right? 6 plus 1 is 7, and x minus 2x is minus x. So we have converted type 2 into type 1. Again, we are supposed to remove this radical sign. So we'll again take the square on both sides. So we'll write it like that. And here again on the right hand side we'll take the square. On the left hand side, square is on 2, it will become 4. Square is on radical sign, it will get cancelled. And on the right hand side, we'll open up the square. It is now the second algebraic identity. Square of first term minus 2ab becomes 14x, and plus square of the last term, right? And here we are supposed to open up the bracket, 4x square minus 4x minus a. And let's move all these terms to the right hand side. Here it has minus 49 plus 14x minus x square equals 0. Now we'll solve all the like terms, same terms, and we'll solve the equation for the value of x. It is 4x square, it is minus x square, it will become 3x square, right? 57 equals 0. Now we are supposed to break down the middle term. Let's use these two factors. And minus 57 equals 0. So that when you can add, you can have the middle term. So let's take 3x common. From here, x minus 3. And then again plus 19 common, x minus 3. Again, x minus 3 is the common factor. So we are having, we'll take it out as a common factor, and we are left with 3x plus 19 equals 0. So here we have either x minus 3 equals 0 or 3x plus 19 equals 0. So we'll having x equal to 3 and x equal to minus 19 by 3. We'll not write down the solution set until and unless we are going to check the values, whether they satisfies the given equation or not. Let's check for x equal to 3 first. So let me write down the equation for you people. Given question, square root of x plus 1 plus square root of x minus 2 equals square root of x plus 6. So instead of x, we are going to write down 3. 3 plus 1, 3 minus 2, and here we are having 3 plus 6. We'll get 4, we'll get 1, and we'll get 9. Open up the square roots, it becomes 2 plus 1, which equals 3. So this means x equal to 3. Set for the value of x equal to 3, it satisfies the given equation. Now we'll check for x equal to minus 19. I'll insert the values directly because the equation is already written over there. So for x equal to minus 19, we are going to have, let's draw a margin. So minus 19 by 3 plus 1 plus minus 19 by 3 minus 2 equals minus 19 by 3 plus 6, right? So again, there are two fractions. We are going to make them a single fraction so that we can see left hand side is equal to right hand side or not. So we are having 3 as an LCM. We'll write down the numerator, and on the right hand side too, we'll write down the numerator. So we'll solve it further. Minus 16 by 3 plus minus 25 by 3, and here again we're having minus 1 by 3. Let's open up the square root. Square root of 16 will be 4, and square root of minus 1 will be iota. Divide by 3. And here again square root of 25 will be 5. Square root of minus 1 is written as iota. 5 by 3. And from the right hand side, square root of minus 1 is again 1, and 1 iota over 3, square root of 3. So if you see, the two hand sides are not equal. Left hand side is not equal to right hand side. So for x equal to minus 19 by 3 will not go into the solution set. It does not satisfy the given equation. So at the end, we'll just write down the solution set, and that value comes in the solution set, which actually satisfies the given equation, which is just 3. And for the other value, we'll write it as extraneous root. Extraneous root is minus 19 by 3. I hope you understand each step of working. Let's solve one more question of the same exercise in which radical equation is given to us. again we are having three radical signs. We are going to remove it so that we can easily find out the values of x. So what we are going to do, we'll square both of its sides. We'll write squaring both sides. So square root of 11 minus x minus 6 minus x whole square equals square root of 27 minus x whole square. So on the left hand side, if you see, we are having the second algebraic identity. So we are going to open the identity. The square of first term means square root of 11 minus x whole square. Then 2ab 11 minus x and 6 minus x, and then the square root of the last term. Since we have already studied that, and this will get cancelled, so here we are having this. How I have written down this the values of the second term, since we have already studied the properties of radical sign, so you can write it separately and you can write it collectively as well. Let's solve. Furthermore, we are going to open up the square, will get cancelled by the square root 11 minus x from the first term and plus 6 minus x from the last term. And in the square root, we are going to multiply the two terms. We are having 66 minus 11x minus 6x plus x square. And on the right hand side, we'll write the term as it is. We'll further simplify the left hand side. 11 plus 6 becomes 17, and minus x becomes minus 2x. And further in the radical sign, 66 as it is, 11 x minus x becomes minus 17x and plus x square as it is. So 27 minus x. So we'll move these two terms to the other side of the equation, so we can have only one radical sign, only one term of radical sign on this side. So 27 minus x, and from the left hand side we are moving 17 to this side, it becomes minus 17 and it will become plus 2x. So here we are going to have we'll further solve, just simplify the right hand side. 27 minus 17 becomes 10, or you can say since we are having x with a plus sign, so plus 2x minus x becomes x, and we are going to have plus 10 on here. So we have converted type 2 to type 1. Here we are having just one radical sign on one side of the equation, so we are going to remove it. Again we will write squaring both sides. So we'll take square on both sides of the equation. And here also we'll just square the both sides. Now square is on minus sign, it will become plus. Square is on 2, it will become 4. Square is on radical sign, it will get cancelled, and you are left with just this term. And on the right hand side we are having the first algebraic identity. When you open it, first term square, then 2ab, then it becomes 20x, and the square of the second term, which will become 100. Now we'll just open up the squares. It's 4 into 66 becomes 264. We have to multiply, we have to expand this. So 4 into 17 becomes 68, and here we'll have 4x squared. Let's move the terms on the right hand side to the left hand side. Become minus 20x minus 100. So let's solve it and rearrange it at the same time. We are having 4x square, it will become 3x square. We are having minus 68 and minus 20, it will become minus 88x. And then we are having 264 and 100, it will become 164. So we have converted the radical equation into simple quadratic equation, and it is in standard form. Now we have to solve it for the value of x. You can apply quadratic formula, you can break the middle term. Let's try breaking the middle term. The two factors that we are going to use is 66 and 82, so that when you add them you'll get 88. So let's take common factors. 3x is common in the first two terms. We are left with x minus 2, and here 82 is the common factor, so again we are left with x minus 2. Further, this whole bracket is taken to be as common factor, so you are left with this thing. So we'll equate each of the factors equals to 0. So 3x minus 82 equals 0. Here we are having x equal to 2, and here we'll have x equal to 82 by 3. Now we'll not write down the solution set directly. For that we have to do the checking process. Either the two solution, these two values satisfies the given equation. Let's see. Let's write down the question first so that we can easily insert the values. Write down the question very carefully. Be careful about the signs. So instead of x, we'll insert 2 first. So we have inserted 2. Let's solve it. We are having 9, we are having 4, and we'll have 25. Let's open up the roots. We got 3 minus 2, and here we have 5. So you see, if we'll solve it, 1 is not equal to 5, so this means x equals to 2 does not satisfy the given equation. The value does not get into the solution set. Now let's let's check it for the value of x equal to 82 by 3, whether it satisfies the given equation or not. So I'm just inserting the values directly since the equation is already written over here. So instead of x, I'll just write 82 by 3. Here this 82 by 3, and here on the right hand side also 82 by 3. So let's solve it further. We are having 3 as an LCM in all the 3 terms. So we'll just solve it. 18 minus 82, and here again we are having this thing, and it will become 81 minus 82. So just let quickly solve it. Minus 49 by 3. From here we have minus 64 by 3, and here we have minus 1 by 3. Let's open up the square root. Square is on minus 1 as well. So when the value of square root of minus 1 is iota, and when we open up the square root of 49, we have 7. So it will become 7 iota by square root 3. Again square root minus sign, and square root is on minus 1. So it will having iota, and square root of 64 is 8 iota by 3. And here we are having 1 iota over square root 3. Now if you solve it further, you see 7 iota minus 8 iota becomes minus 1 iota. Here we are having plus 1 iota, and here we are having minus 1 iota. So these two are not equal fractions. So this value again will not come to the solution set. So now you clearly see there is no value of x which satisfies the given equation. So our solution set will be empty. Right, it will remain empty, and these two values will go as an extraneous roots. So we'll write 2 and 82 by 3 as extraneous roots. So hope you understand each step of working. Thank you so very much. Let's move further to another sum. Let's solve question number 8. Which is of type 2. This is the last question of this type, in which we are having 3 radical signs. So we are going to remove the radical sign so we can solve the equation for the value of x. So how we are going to remove the radical sign? We'll take square on both sides. We'll write squaring both sides. On the left hand side, we'll have square root of 4a plus x, then minus square root of a minus x whole square. And on the right hand side also we'll take square. On the left hand side we are having a minus b whole square. So we'll open this algebraic identity. We'll apply the formula, which is of a square minus 2ab. So we'll multiply these two terms. It becomes ab, and then b square, which is the square of the last term. So the square root of a minus x whole square. Square will get cancelled on by the root on the right hand side, and we are left with just a. We'll further simplify the left hand side by opening up the square. Square will get cancelled by the root. Here we are having 4a plus x. Now in the last term, square will get cancelled by the root, and we are left with a minus x. And for the value of 2ab, you are going to multiply these two radical signs. So 4a plus x, since we have studied the property of the radical sign, which is that if radical signs are written separately, you can write them collectively. So you have to multiply ab, the two terms which are under the radical signs. So 4a plus a becomes 5a, and this plus x minus x become cancelled. Let's see how we are going to multiply the two terms under the radical sign. We just have to expand the two terms. 4a into a becomes 4a square, then minus 4ax, then plus ax, and then minus x square, which equals a. We'll move 5a to the other side of the equation, and here we are left with 4a square minus 3ax minus x square, and when we move 5a to the right hand side, it will become minus 5a. Let's further simplify it. So we are going to write, since now we are going to have just one radical term, so a minus 5a becomes minus 4a. So we have converted type 2 into type 1. So here we are going to even, let's say, we can even take minus 2 to the other side, so that our terms will get more simplified. So minus 4a over here, when minus 2 will go to the other side, it will get divided. So here you are left with just, let's solve it, 4a square minus 3ax minus x square. We are left with just 2a. Now we are just having one radical sign on this side. So how we will remove it? We'll again take the square on both sides. Let's say squaring both x square whole square, and on the right hand side too, we'll take the square on both sides. Square will get cancelled by the root, and we are having 4a square minus 3ax minus x square, and it will also become 4a square. Let's solve it further. 4a square minus 3ax minus x square, and this 4a square, let's move it to the other side. Let's see, 4a square will get cancelled by 4a square, and we are left with, let's say, we can take minus x as common. From here we are left with 3a plus x, which equals 0. So either we'll write minus x equals 0, or we can write 3a plus x equals 0. From here we'll get x equal to 0 as an answer, and here we are having x equal to minus 3a as an answer. Now we cannot write down the solution set until and unless we are going to check the values, these two values for the extraneous root. Let's do the checking process. So we are going to write down the question first, so that it will be easy for us to insert the values. Write down the question very carefully. So instead of x, we'll write down 0. Instead of x here again, we write down 0. So 4a becomes 2 square root a. Here it can say like this. So when you solve it, we are left with just 1 of square root of a, which is equal to this. So these two terms, these two sides are equal. So 0 will get into the solution set. Now we are going to check for the, insert the values directly. So instead of x, I'll write down minus 3a, and instead of, this is minus sign, this minus sign is of the equation, and instead of x, I'll write down minus 3a. Let's simplify it. 4a minus 3a becomes a. Here we having a minus to minus plus 3a, and let's see how the things are going to come out. A plus 3a becomes 4a. When you are going to open up the square of 4, it will become 2 square root a. And when you subtract 1 minus 2, it will become minus 1. So we are having minus a square root a, which the two terms are not equal. So the left hand side is not equal to the right hand side. So this term, this x equal to minus 3a, will not go into the solution set. So at the end, we'll write down the solution set. So 0 will go into the solution set, and extraneous root will be minus 3a. So hope you understand the sum. So these are the radical equations of type 2, in which we have taken square 2 times, right? So that we can remove the radical terms, and we can easily find out the value of x. Hope you understand the steps, each step of working. Still, if you don't, you can ask me, you can write down in comments. Thank you so very much. Allah Hafiz.